Find the velocity of piston when it is a height L/2 from the bottom of cylinder. So this height should be how much, no? Okay, read question. Meanwhile, I'll adjust the things here. This one. Okay, this side should be L/2. We have all the information, thermal conductivity. Find the velocity of the piston when it is height. Is asking this velocity V. Side of the question little bit. Okay, no, I think you are able to read. Yeah, we have here. There are some very few good words are there. What do you mean by that? Well-lagged, steady state. The meaning of this steady state. Rod is well-lagged means at steady state. So what will be the temperature? What will be the heat flow through the rod will be constant. And as a negligible heat capacity, it will not absorb heat. Only what this rod is involved only in the transfer of heat. Temperature of gas remains constant. I think unless you don't make notice of this, not possible. I'm just picking up the questions which are of some advanced level and multiple ideas are there. So what process the gas will undergo? What process the gas will undergo? Isothermal process. So first you identify what process the gas is involved. Isothermal process. Next, after getting this, as the gas undergoes isothermal process, so what all, why do heat will flow through the rod? Let's check it here. The piston is moved again. The piston is moved such that moved means some external agent only will move it. No, sir. What about atmospheric pressure? He has not mentioned. P naught if he gives, you can go for it. So P naught is not needed. Put P naught 0. He did mention. If he says atmospheric pressure, then you should take that also into the picture. Okay, let's come for that one. Who will push this piston? External agent. And then what is the isothermal process? Q equal to W, no? Constantly what happened? The external agent is doing work. And what all work done by external agent, what will happen to it? Will be converted into the heat, will be generated in the gas, and that heat will be transferred by the rod. So dq by dt is equal to dw by dt. So what is the isothermal process? Which will convert mechanical work into heat, and that heat generated in the gas will be transferred through the rod. That's why the temperature of gas remains constant. Okay, this is nothing but H. You can write H is equal to that. H is what here? The moment H word comes, I think you can write it some equation. Ka delta T by L. Delta T is what? Not temperature difference of the gas. Temperature difference. Let me attend. what is delta T? Temperature difference 27 minus 0 that you substitute, and we know length of the rod is L, K is their area of cross section. We know this one dw by dt. What to write? Okay, I'll get into the isothermal process. nRT log of work done, or PdV. Shall we go for it? nRT by V dV. dV is what? What is the volume when it is volume of gas is like a AL by 2. And what is dV? dV you can write it as A into dx. So then this will become nRT can you hear me?
Yes,
Yes, sir.
No power. I think from yesterday we have same problem. Okay, we'll continue with the mobile data. This NR to nRT by L. This is dx by dt. I'll write it. What is T? T is the temperature of gas, 27 degrees Celsius. Substitute this, and this dx by dt is what? Find the speed. Even L gets eliminated. So Ka delta T by 2 nRT is equal to V. Fine. So what all that heat what will happen? Generated in the gas that will be transferred by the rod. Since it's in a steady state, no? So I'm moving. What happens if I accelerate the rod? If I accelerate the rod, the dq by dt what happen will not be a constant. Then h will not be constant. Then the power flowing through the rod will not be constant. So at steady state only we are able to write this equation. If h varies, then dh by dt will come if I accelerate. I'll give the velocity. You check calculation later on, 5 millimeter per second.